All right, today we are adding and subtracting radical expressions. So the purpose of today is to simplify our radical expressions so that we have like radicals so we can add and subtract them. So the first thing I want to mention is that a radical kind of takes on the characteristics of a variable. So the same way if I had 2x plus 3x, it equals 5x, the same thing's going to happen if I have 3 red 7s plus 5 red 7s make 8 red 7s. Okay? So in the next one, we're going to have 5 red 3s minus 1 red 3 make 4 red 3s. Pause the recording and try the next two on your own. All right, let's check your work. So the first one, I have 2 red 5. And then I have a 1 red 5. So 2 and 1 make 3 red 5. Minus 7 red 5 make negative 4 red 5. The next one's a little bit different because they're not all like radicals. So the first one I have 6 red 2. And then I have a 1 red 2. And 6 minus 1 is 5 red 2. And the other one is not a like term, so we just write minus 2 red 6. Okay? Let's keep going. So, what does it mean to be a like radical? The radical has to be the same. So a red 7 and a red 7. If I have 3 red 7 and 2 red 7, I have 5 red 7. Whereas if I have 8 red 7 plus 3 red 5, they cannot be added. Just like with variables. 7 red 11 minus 3 red 11 makes 4 red 11. Whereas 6 minus 2, red 6, we cannot, this is a very big mistake that everybody makes, we cannot subtract that before we multiply this. So it's about order of operations. So it's really 6 minus 2 red 6. You cannot do 6 minus 2 and get 4 red 6. Next one is red 10, red 10. Notice the coefficient's there that we don't see it. It's a 1. That's why we have 2 red 10. Notice every time your radicals are not changing. Only your coefficients are. So if you look at red 5 plus 5 red 2, because the radicals are not the same, they're unlike terms. So here's what we're going to do. It seems like they're unalike, but once we simplify it, red 20 becomes 4 red 5, and that really becomes 2 red 5 minus red 5. They really are like terms. So 2 red 5 minus 1 red 5 makes red 5. I'd like you to try the next one on your own. Now let's check our work. 32 becomes red 16 and 2. 18 becomes 9 and 2. So the square root of 16 is 4 red 2. And the other becomes 3 red 2. So 4 red 2 plus 3 red 2 makes 7 red 2. Next. Let's do the first one together. So, what do we do to 12? How about Elise?
Well, 12 can be simplified to rad 4 times 3. And then 27 can be simplified to rad 9 times 3.
And then it becomes?
2 rad 3 minus 3 rad 3. And the answer is negative rad 3.
Good. Okay. Pause the recording and try the next 3 on your own. All right, let's check our work. So, who wants to do the next one, number 2? Okay, go, Jamie.
I broke down rad 72 to rad 9 times rad 4 times rad 2.
So he probably originally went 8 times 9. And so he did rad 9 times rad, and that 8 is really made up of a 4 times a 2. Or we could have done 36 times 2. And then minus, how did you break down the 8?
Rad 4 and rad 2.
Good. And so now I'm getting
3
times 2. I can pull out a 2, and we're left with a rad 2, which is 6 rad 2. And the other one?
It's negative 2 rad 2.
Okay. Now are these like terms? Can we subtract them?
Yes.
It would be?
4 rad 2.
4 rad 2. Okay, next one. Go, Brianne.
So I broke down rad rad 25 times 3 minus rad 16 times 3 plus rad 3.
And that becomes?
That becomes 5 rad 3 minus 4 rad 3 plus rad 3.
Good. And then 5 minus 4 is?
1, so it's rad 3.
Wait a second. 5 minus 4 is 1 rad 3
And then
plus another 1 rad 3.
2 rad 3.
2 rad 3s. Okay, how do we break down the last one? Gracie, go.
The last one breaks down to rad 9 times 10, and then minus rad 4 times 10, plus 2.
4.
4 rad 5. 4
Okay,
times rad 5.
okay.
And then those break down to 3 rad 10 minus 2 rad 10 plus 2 rad 5, and then you add together the two like terms, so you get rad 10 plus 2 rad 5.
Okay, are there any questions? All right, let's keep going. We're moving along. Halfway through the lesson. Okay, so now we're going to add variables. So when I break down 50, how do we break it down? 25 times 2, and we have a y squared there, minus 4 times 2 times y squared. Now, what do I simplify that to? 5y rad 2 minus 2y rad 2. Now, pay close attention with these variables. 5y minus 2y, because these are alike, we can subtract them. It's 3y rad 2. Does that make sense, Nicole?
Yeah.
Okay. All right, you want to try the rest on your own?
Yeah.
Pause it. Okay, let's go. 12 breaks down to, whoa. Go, Mike. 4 times 3, x to the 4th. This breaks down to 9.
3x to the 4th.
And how do I simplify it?
2x squared rad 3.
Plus
3x squared rad 3.
Good. And since it's 2x squared plus 3x squared, that makes 5x squared rad 3. Next one. I have a 5x, and in here is a 1. Outside is a 1. The 125, how do I break it down? 25 times 5. Did you say times 25?
No, I said 25, or 5
Okay.
times 25.
Okay, and then we have x squared x. So this is then going to become a 5. I can take a 5 out, and I can take an x out. And what's left under the radical is 5x plus, and then we have the 1, right, over here. So now I've got 1 plus 5x, right? 1 plus 5x, all times the square root, all times the square root of 5x. Now, since they're both times the square root of 5x, you have to put those parentheses or it will be wrong. Otherwise, it just means 5x times rad 5x, not the whole thing. Does that make sense? Mm-hmm. So on the next one, we're going to end up with 4n squared minus, when I break that down, it's a 4 times a 5 and an n squared. So I end up with 4n rad 5. And I've got my 4n squared minus. Do I need a parenthesis now?
Wouldn't you end up with 2n rad 5?
Uh-huh. Do I need actually, let's look at this. I think we can factor that. No, we can't. I think it's going to be, in this case, when we're doing it, do we need the parenthesis around it?
No.
No, because look. It's not like this is also supposed to be multiplied by that rad 5. Does that make sense? Mm-hmm. All right. So now what do you think we do on this one? Take a minute, write the problem. Okay, what do we do first under the radical? What do you think? Nobody knows? Yeah, what's the GCF?
Oh, 9, sorry, 9.
And then what's left?
X squared plus 1.
Good. What do I do in the next one under the radical?
What did it be? X squared.
Of x squared, and what's left? Okay, so what's the square root of 9?
3.
And then I'm left with the square root of x squared plus 1. Plus, what's the square root of x squared?
X.
And I'm left with x squared plus 1. You can put it in parentheses or don't need to because there's nothing next to it. So now, will I need a parenthesis or not?
Yes.
We're doing 3 plus x, have to both be in parentheses, times the square root of x squared plus 1. Did you write that down if you didn't finish it?
Can't it be 3x since you're adding it?
No, that's 3 times x when you say 3x. It has to be 3 plus x. All right, can we move on? Are you still writing? All right, next, we are going to factor out again, because Julia said, but I forgot to hit the recording. What is it, Julia?
You factor out a 9a squared.
9a squared. And what's left?
A minus 2.
Good. And under the radical, what am I factoring out?
A 4.
And we're left with a minus 2. So in the first one, we end up with a 3a times rad a minus 2. Plus here, I end up with 2 times, rad a minus 2. So 3a plus 2, the quantity, times radical a minus 2. Yes, questions? All right, let's keep going. Okay, here we go, the fractions, fun. Okay, so you have 2 jobs to do when you have fractions like this. One is with radicals, you have to make sure to, before you can add or subtract them, you need a common denominator. So we're going to be multiplying by the fancy 1. The other is we need to rationalize the denominator. It doesn't matter what you do first. So if you want to get rid of the radical in the denominator and then get common denominator, or you can get common denominator and then, I think it's probably best to rationalize first. I did it the other way and I think it was twice as long. So get rid of your radical. How do I get rid of the radical in that second fraction?
Multiply times the fancy 1.
Which would be
5 over 5. No,
what?
5 over 5.
Not 5 over 5, but
Rad 5.
rad 5 over rad 5. And then I have rad 5 over 1 minus rad 5 over 5. Okay, now what? Common denominator. What do I need to do?
Find
By what?
5.
5 over 5. Not rad 5 because we need the denominator now to be 5. So then I end up with 5 rad 5 over 5 minus 1 rad 5 over 5. And so what do we end up with?
6 rad 5 over
5 minus 4 rad 5 over 5. Got it? Do you want to try the next one on your own? Okay, pause the recording. All right. So let's rationalize first the equation on the left. What am I going to multiply by? What? To rationalize the equation?
It would be rad 3 over rad 3.
Rad 3 over rad 3, and the equation on the right?
Rad 6 over rad 6.
Good. Okay, and then I end up with rad 6 over 3, and then I'm going to multiply by rad 6 over rad 6, and we get rad 6 over 6. Now we're going to common denominator. Which fraction do I have to manipulate? The first one I'm going to multiply by 2 over 2. And then we get 2 rad 6 over 6 plus 1 rad 6 makes what? 3 rad 6 over 6. Am I done? Because that can be cross-canceled to 1 over 2. So it becomes rad 6 over 2. Okay, questions? All right. And that's the lesson.